Okay, so this is a tutorial on motor drives for a DC motor, and we have earlier seen how a DC motor works, and now we are focused on looking at the single-phase drives of a DC motor. So if you connect, so basically this is how the DC motor with a DC drives look like. So you connect a converter at the AC supply voltage on the armature current circuit, and you apply another converter at the field circuit, which converts the AC input supplies. In this case, we are looking at the single phase AC supplies, which are then converted into DC for the motor and the field circuits. So basically, there are four types of single phase drives based on the different four types of converters, and that are half-wave converters, the semi-converters, full converters, and dual converters. So let's begin with the single phase half-wave converter. This is a pretty simple motor drive. It just has a single thyristor at the input of the armature circuit, but the field circuit uses a semi-converter, because using a half-wave converter at the field circuit, which will generate huge magnetic losses because the field current would be very discontinuous. So it's advisable that you use a semi-converter at the field circuit. Now, looking at the armature circuit over here, we can see that since it's a half-wave converter, it uses a half-wave converter drive, so obviously it's going to operate in just one quadrant. And when the positive half cycle hits, this is a positive, and the current will flow on from here through the motor and back to the source. In case of the negative half wave, obviously it won't conduct, and so the output would be zero. But the inductor would, and when you connect a highly inductive load in a series to the motor, it will ensure that the current you get is nice and continuous. You also need a freewheeling diode when you have an inductor, because you want that the energy that comes back should be fed back so that it doesn't damage your components. So from the waveforms, you understood what this waveform basically means. Highly inductive load ensures that you have a continuous current. Looking at the current which flows through this thyristor, obviously the current will only flow when you apply the firing, when you fire or trigger the thyristor, and it should also be forward biased. When that happens between alpha A, which is your firing angle, and pi, because after pi the voltage reverses and it is in reverse bias then. And when the thyristor conducts, the diode doesn't conduct, and when the thyristor doesn't conduct, the freewheeling diode conducts and pushes the energy back into the inductor. So that was single-phase half-wave converter. The single-phase semi-converter drive is also a single quadrant drive, and you'll see that the current flows in from here through the motor and gets back over here. When the negative cycle comes, the current then flows through these pair of thyristors, right? And even here you're going to use the semi-converter at the field circuit as well. So these are the waveforms for a semi-converter drive. Now let's look at the full converter drives. So these operate for two quadrants. So this works in two quadrants, and So one is the motoring and the other is regeneration. And the field circuit is also a full wave converter, because it needs to reverse the polarity at the field current to ensure that you're getting into the regeneration mode. So these are the equations which you get for a single phase full wave converter. That's nothing new. So again, the current is always going to be continuous when you have a highly inductive load connected to it. So what happens here is you are able to pass the current through the motor in two quadrants, even when the voltage is negative. And the dual converter is it allows the motor to work in all the four quadrants and all the four different modes of operation, which is forward motoring, reverse motoring, forward braking, and reverse braking as well. And the field converter is a full wave converter. It can also be a dual converter, but a full converter is sufficient enough for this to work. The armature circuit has a dual converter, and at a given time, either the positive group works or the negative groups works. And yeah, that's pretty much